Hello all, welcome to Unit 1. We're covering Think Java, chapters 1 through 3. So if you remember from the course overview, we're using two different texts for this course. The first one, Think Java, is being used for the first 5 units of the course. So this video, and probably one or two more, are going to be used to cover chapters 1 through 3. I'll probably need to use 2 or 3 different videos because I'm limited to 15-minute videos with the software that I'm using. I'm going to be covering this material in broad strokes, but by no means does it replace you reading the chapters and outlining them in depth is what I would recommend, because we're going to be returning to Think Java throughout the entire term because it gives us the basics for programming in Java. So you'll need to come back and refer to these chapters time and again. We're using IntelliJ as the software for this course with the Java JDK. Make sure before you commence with writing programs or even finishing this video that you go to Course Software, Software Installers, and watch this video for installing the JDK and IntelliJ, which the links for those installations are here, and this video will explain them. So do that before you do anything else. So why computer programming? Well, computer programs manipulate electronics to be able to arrive at solutions very, very quickly. We can do thousands, millions, billions of executions per second by using computer programs. And the purpose of computer programming is to solve problems through intelligent design and repetition. According to the authors, a program is a sequence of instructions that specify how to perform a computation. Well, to get to the meat of that is, in writing programs, we need a computer information cycle employment. In other words, we need to get input from users, either through a keyboard, a sensor on a scanner, or another file, or some other device. We need to process that information by using basic math operations, addition, subtraction, multiplication, division, etc. And last, we need to be able to output, in other words, display data or send that data to another file or device. That's all there is really in computer programming. Information processing cycle. We have inputs, processing, and outputs. And typically, a computer programmer will start with the outputs. In other words, what do you want your program to do? What is the end result? You start with that. You see what potential inputs you have, how you can manipulate those inputs through processing into the desired outputs. That's basically all there is to it. Now, the sequence of instructions that need to be followed, sometimes they're step-by-step, but rarely. Usually what we have to do is employ decision-making. We have to have conditionals. If statements is one example of a conditional. If this happens, then we do this. If another thing happens, then we do that other thing. So there's a combination of conditions and repetition. It's said if decisions make computers intelligent, it's repetition that makes them useful. In other words, if we're processing through hundreds of thousands of records, we would not want to write the instructions every time we need to for the next record. We would just want to be able to refer to those instructions again. And that is repetition, and that's what makes computers useful, fast, and why we use them today. In order to use computers, programs follow a pattern, typically. And that pattern, there are whole courses on computer patterns and algorithms. So the algorithm is the pattern that is employed for a particular computer program to solve a particular problem. And it gives the series of steps, the decisions that need to be made to solve that problem in general. I mean, every program is unique unto itself, but most patterns can be adapted to fit the desired result. And the programming language we're using in this class is Java. Java is a high-level language that translates the code that you write into lower-level machine language. Machine language are the zeros and ones, the electronics that the computer can understand and send to another computer. But they start off as high-level instructions written in English-like statements, for the most part, that need to be interpreted by a machine. So there are two types of programs that a high-level programming language fits into: an interpreted language and a compiled language. Java is both interpreted and compiled. An interpreter reads a high-level language and executes it a little bit at a time. A compiler converts the entire program into bytecode, B-Y-T-E, and bytecode is the file that's created. So in Java, we have a Java file that we write in, but then that is converted to a bytecode, which is a .class file. So we don't work with the .class file, we generate it after we're done compiling the Java file. We'll get into that more later on. But as I said, Java is both compiled and interpreted. And so what happens is the bytecode is created and executed on by what's called the Java virtual machine. The Java virtual machine is a way that Java can be written on one type of machine and interpreted on that machine or other types of machines. So for example, if I write Java on a Mac and the bytecode is created, that bytecode can be used by a PC. So there are, it's said that Java is a language that you can write once and run anywhere. That's how it used to be advertised. So that's kind of an overview of, just a really basic overview of what computer programs do. Again, we think about the information processing cycle, input, processing, and output, and on the type of language that we're working with. So to keep both of those things in mind, let's go ahead and create a simple program using IntelliJ. So when you downloaded and installed IntelliJ, it would have put it in a JetBrains folder, and we have IntelliJ IDE. Okay, so we come to the IntelliJ opening screen and we're going to create new project. Now, every program that's created, so at this step I'm going to say, double check that I've got version SDK 11 here, and I'm going to click Next. And initially, you're going to be creating projects from a template. You're not going to be, later on we're going to be doing other things, but right now just choose Create Project from Template because it will include a main method. Now a main method is necessary because each part of a program has to have a hook, the thing that makes it work, and that is the main method in Java. So, okay, the next thing we have to think about is where do we want this saved? So we've got project location, and this is really important. because you want to save things where you can find them again. So I'm going to click this ellipsis. Okay, I don't want it in class 5. I probably want this in my class 1. Actually, I've got another path that I want because I've got let's go back, cancel, hit this again, and I don't want it here in 2467. I want it in my 2467 new, and I'll put it in class 1. Okay, so this is an example of how you manipulate the folder structure to where you want to save things. Okay, so I've got it saved there, and now I have to give it, I don't want to call it class 1. Class 1's the name of the folder it's in. I need to have a name for this. I'm going to call it, how about example 1, and I'm going to say finish. Okay, and it's creating this. Okay, so when I create a file, I've got two things that are happening right away. I am creating, we'll talk about package later, but I'm creating a file, and that file is a class. We're going to get into classes and objects and all kinds of things later on, but right now just know that we have a class that gets declared and begins with a capital letter. In this case, the default, since we use the template, the default class is main, starting with M. We've got then a main method. That's what this is referred to. And when we start coding, we've got the main method here. Now, one thing I want you to notice in Java here is we have these curly braces. So we have an opening curly brace for class, and we have a closing curly brace for class. We have a opening curly brace for the method, and we have a closing curly brace for the method. It's important to keep these things in mind as you're coding because the curly braces go together with different sections of code. And so you're going to be using a lot of curly braces as we go here. So we have two lines here, two slashes. That indicates a comment. Comments are not executed. They are for the purpose of writing, or I should say, the purposes of internal documentation. So, in other words, I wrote this program. And by the way, for every program that you turn in, you need to include your name. Your name, lab number, and your date. Not used to writing 2021 yet. Okay. So we've got that initial part of the code, and notice that I just hit enter and it pushed these down. That's because whatever we're writing, we're still in the main method. Now, as we get deeper into the course, you're going to see we're going to have multiple methods. So this is one method. I can just hit enter after this, and I could create another method after it. And we'll discuss methods more in detail later on. Right now, you're just going to write everything in the main method for the first week at least. So we're going to go ahead after our comments, and we're going to create a simple program to get input and display output. Now, I'm reaching the end of my 15 minutes here, so this is going to be part 1 of the video, and I'm going to pick that up in part 2.